Okay. Good morning, students. Now we are going to take on the topic of sound. So, what is sound? Sound is also a form of an energy. So, if anyone can ask what is light, what is sound? So, both of us is a form of an energy. So, here the sound is produced by the vibration of mechanical energy. So, here the mechanical energy is converted into the sound energy. So, sound required a medium to travel. For introductory systems, in introduction, I said that sound require a medium to transfer from one place to another. But light does not require a medium. The light can able to travel in the vacuum space, but sound wave can unable to travel in the vacuum. It require a medium. The sound can able to travel in the solid, liquid, or even in the gas. The sound is travel faster in solids, and when compared to the solid, it will slow. The velocity of the sound is slower in liquid as well as in the gas. So it shows that the sound wave require a medium to travel from one place to the another place. Or sound is a form of an energy. It can be produced by the vibrating systems. Then only we can able to produce the sound. Okay. Now we are going to take on the topic of sound waves. Already we say that sound is a form of an energy. Then another question will arise. What is sound wave? The sound wave is the pattern of disturbance. That is a disturbance, pattern of disturbance caused by the energy traveling away from the source of the sound. It is a pattern of energy. Sound wave is nothing but as a pattern of disturbance. The disturbance is produced by the any vibrating body. Okay, that is called as sound wave. So now we are enter into the Doppler effect. It is a very important question asked in most of the UG level as well as in the PG level. So the application of Doppler effect is used to determine the velocity of the wind during the climate changes or to predict the forecast of the climate, and it is the Doppler effect. What is the Doppler effect? Doppler effect is the phenomena. It is the provide or give the relation or between the source and the observer. It provides the relation between the source and the observer. It is called as Doppler effect. Whether the source is moving toward the observer or the observer moving toward the source. For example, in this diagram, I clearly explained what is going to happen in the Doppler effect or what is Doppler effect. Here is the horn producing the sound. It is a stationary sound source. It is a stationary sound source. If the horn is placed in the car, okay, here the observer is standing. If the car is moving towards the observer, what will happen? The observer can able to hear the sound in large manner. Suppose if the source is moving away from the observer, what will happen? Normally the sound heard by the observer is very very low. So what it shows that the relation between the source and the observer will provide the Doppler shift. Okay, we can able to explain by use of the equation. Here f dash is the observed frequency, f is the actual frequency. In the formula we can able to find the frequency. Okay, v is the velocity of sound wave. V is the velocity of sound wave. V naught is the velocity of the observer. V naught is the observer who is standing on the observer system. Okay, and Vs, here Vs is the velocity of the source. Okay, so now we can able to find the frequency shift happen in the Doppler for the sound wave as well as in the for the observer and the sound wave. It is predicted by the Doppler. So now we have taken the two conditions. First condition is the source is moving towards the observer. Like, so now I am going to explain here. In this diagram, the source, that is the sound horn, is there. It is placed in a vehicle. Here is the observer. The source is moving towards the observer. Then how the equation here changes. Now we are going to explain here. So what will happen? Here is the above formula. the observer is at rest, so that there is no velocities, no. The observer is at rest means velocities became 0, so that the above equation can turns to V, because V naught became 0. V divided by V. V is nothing but as, already know that, velocity of the sound wave. So here V minus, here Vs. Vs is already know that Vs is nothing but as velocity of the source. Velocity of the source. So actually what is represent if the observer is at rest but hear the sound? What is the relation? How can we find the velocity, or how can we find the frequency of the source? By using the formula. By finding the velocity of the source, it is to the velocity of the source to the velocity of the normal frequency of the sound into frequency of the actual frequency of the sound wave, we can able to determine the source moving towards the observer is at rest. This is the first condition. Second condition is source moving away from the observer at rest. So here is the second condition. Observer is at rest but source is moving away from us. It can be explained in this diagram. So here is the source. The observer is at rest, but the source is moving away from the observer. How the equation can be changes now? Already we know that f dash is equal to V plus V naught divided by V minus Vs. F. Actually we mentioned f dash is the observed frequency, actual frequency. V is the velocity of the sound wave. Vs is the velocity of the source. Now we are going to the second condition. The source moving away from the observer at rest. The source is moving away from the observer. The above formula can be rewritten as V divided by V minus, here putting V minus V. Yes. What is actually is represent? The velocity of the sound is decreasing. So that only the Doppler put negative sign in the above formula. V divided by V minus Vs. By this formula we can able to determine the relation between the frequency as well of the sound wave to the observer as well as the source. Okay, thank you students.